Hey everybody, welcome to a video talking about the metric system basics. And in this video, we're going to go over all the things that you kind of just need to know about the metric system in order to be successful in this class. So get ready, we're going to kind of zip through this stuff because many of you already know a lot of what's here, but some of you may not. So let's get started. So just so you know, there's several systems of measure that are used in the world. Okay, even currently, right now, the United States sometimes uses the U.S. customary system of units, and a more common system of units is the metric system. That's what this video is about. But even so, there's other systems of units like the empirical units that are used by countries like Liberia, and even Burma has their own system of units that is controlled by the government there. So everybody kind of has different systems of units that are used, but by far and away the metric system is the most popular. And most of the world, this should say most. Look, I made a typo in my notes. Let's say here, this should say most. Most of the world, including the U.S., uses the metric system. And the reason why I say that is the metric system has equivalents in the U.S. customary unit, but in the U.S. customary system. But the example that I want to give you is an inch. Okay, 1 inch, that's a U.S. customary length. But did you know an inch is actually not defined by anything other than this number, 2.54 centimeters? So actually an inch could be considered a metric unit because it's defined by a metric thing. Years ago, they got rid of like what an actual foot was. They just defined it as 12 inches, which is then defined as 2.54 centimeters. So it's kind of interesting to think that we're not as independent from the metric system as a lot of people think. But the metric system is really beneficial because it is based on 10, which allows conversions very easily. And it's easy, because it's based on 10, it's easy to scale numbers up and down. And we'll talk about that at the end of this video. And the other thing about the metric system, which is good for chemistry and physics and biology and all this stuff, is that it's really scientifically well defined. Scientists have spent years making sure that a second is actually a second, and then a meter is actually a meter. So those units are very standard and don't change. And that's one of the things that we need to make sure we understand about the metric system. There's no other system in the world that is defined as rigorously as the metric system. Now, in the metric system, there are units that we're used to seeing. Okay, I'm sure it's no surprise that a meter is on this list, but there are only 7 units that we call base units in the metric system. Anything else that's not listed on here as a base unit is what we call a derived unit. Okay, and now when I say a base unit, for example, I'm going to say centimeter. This is based on a meter, and so this is a base unit. Okay, just adding the prefix doesn't change it from being a base unit. Okay, the length of time, or the length of something can be measured in centimeters or meters or whatever. Okay, the most popular example of a derived unit would be a liter. Liter is nowhere on this list, nor is kiloliter or milliliter or whatever you want. So a liter is kind of the most popular derived unit. Other things that you may know are things like calories, horsepower if you're a gearhead, all these things. Okay, since calorie, horsepower are not on the list, they're a derived unit. Okay, something like a milligram. Okay, well, here's kilogram. Okay, so this is a base unit because, yeah, it's got a prefix in front of it, but it's still from the kilogram. Okay, now this brings up a good point about prefixes. Okay, the metric system has a whole bunch of prefixes. There's a whole bunch that extend up, and then there's a whole there's a whole bunch that extend down below these. Okay, for example, giga, the next one above giga is tera, if anybody knows computer lingo. Like, we have gigabytes of storage, but then there's things that hold terabytes of storage. Okay, and pretty soon, probably in 3 or 4 years, terabytes are going to be the things that we are used to using. Okay, below micro, there's things called nano. Okay, so nano is the prefix below, and then there's more and more and more below them. But these are the 6 most common that I wanted you to kind of have in your head and kind of be able to refer back to. Now, I did put in here no prefix, because that is an important placeholder when we get into doing conversions. Okay, but this would be something like a meter or a gram. Okay, and so those, when they don't have any prefix, it just means 1. Okay, so what's the deal with all these prefixes? I think that that's important to go over, because these prefixes, like, they can get confusing. For example, there's mega, which is capital M, and then there's milli, which is lowercase m, and then they're out of M's, milli, so they have to go to micro, which is a Greek letter M. That's a mu. So this is the deal with these prefixes. The human mind can only comprehend numbers that are so big and numbers that are so small. Let me tell you that 150 billion is a number that is too big for the brain to comprehend. If we had 150 billion of something, our brain wouldn't be able to comprehend what we see. That's why they hire a whole bunch of people to count, or they hire agencies to count things at huge events. When, they take aerial photos, and then they can estimate how many people are at events based on packing rules. And so if it's over like 100,000, our brain can't understand it. So when we see a crowd of 3 million, we don't know that it's 3 million. It may be 500,000. It may be 20 million. We don't get it. But here's what our brain can do, is we can take this, and this is, I'm going to write this in English. This is 150 billion meters. So instead of saying 150 billion meters, we can go back. What prefix means a billion? Well, giga. So why don't we say 150 gigameters? Yeah? And now our brain can kind of understand 150. Now, it doesn't change the value of the number because we've put the prefix in there, but it's a little easier to deal with when we're doing math and trying to understand that quantity of things, or that, whether it's meters or whatever. Okay, so it's a little easier to understand. The same is true with really small numbers. This is 17 millionths, right? Let's see, thousandths, millionths. And like, I had to look up how to read this number. That's no joke. Okay, and I'm an old chemistry teacher, and I had to figure that out. So who wants to actually say 17 millionths? 17 millionths, of a meter. Why don't we find the prefix that means millionths? We go back down here, look, it's micro. And so why don't we just write that as 17 micrometers, right? And then everything seems to be cool and copacetic. The same is true with here. A mass of a grain of sand is 67 millionths of a gram. So instead of writing it out with all those decimals, why don't we just write 67 micrograms? And that still conveys the same thing, but now our brain can kind of understand that number, and maybe we could do a little bit of math, because 67 is a little easier number to deal with than 67 millionths. So all of this combines into what the kind of the basics of the basics of the metric system is. It's the metric system is about knowing the units, the 7 base units, and about knowing prefixes and kind of being able to understand why there are prefixes. So, yeah, so that's this video, and have a great day.